So our code is split into 3 files inside the team code folder, inside the Java folder, inside the org folder, First Inspires, FTC, team code, all those folders. That's where we put our Java files. And I'm working inside of Android Studio right now, which is a great place to write code for your robot. So the robot and README files I'm not going to be talking about because we are not using them right now. Right now, the files that our code is in are the testbot file, the testbot controls file, and the constants file. Now, you'll see that here they don't have the .java extension, but it will show up when you open it up in a tab. So first, we can look at the constants file. This file right here just defines 2 variables. Now, I shouldn't say variable. I'll say constant, and that's because, first of all, it's final, and that's a keyword in Java. And second of all, because it's in a file called constants, you might as well only put variables here that are so-called constants. And what that means is they don't change throughout the time that your robot, that your code runs on the robot. So, for example, something that does change is how fast it's moving. Right at the start, it's moving 0 feet per second, and then it might start speeding up. That would be a variable. Its speed is a variable. However, its turn power, we decided it should be a constant. And by turn power, what this means is how strongly the robot actually turns, as in when we turn the robot, one thing that we started noticing was if we had it going at full speed, it would turn way out of control. And so this turn power is less than 1, meaning that the power gets scaled down. You can imagine if before it was turning at 100%, now it's turning at 0.3 or 30%. Now, we can use, the reason we have this in a separate file is because we can still use it inside of other files. For example, here you can see that we import stick_thresh. Stick_thresh is a variable that we have, is a constant, that we have that defines how much one of the sticks on our controller needs to actually be pushed up or down before it registers as a movement and not just an accident or a little twitch. So let's go through the testbot controls file and the testbot file, and that's all that we need to get the robot moving. Perhaps I'll start with testbot controls. So the first thing that this file you'll notice is it has its imports and its package. I won't go over those, but if you want to learn more about it, you can look into how Java works and what the import and package do in Java. But the idea is this package will be the same for you as long as you had the same folders. And these imports tell you what code you can use from other files and from other parts of the library that controls the robot. Now, this right here, public class testbot controls, is the main class from this file, and this name should match the file name without the .java. And then inside of here, this is where we're going to work with and interface with our actual robot. So the hardware map. So first of all, this is a constructor method, and again, I'm sort of assuming that you know a little bit of Java, but the idea is that when your code will run, this method right here will execute because the robot will be created. In fact, we create that robot behind the scenes. And what you do here is you have it take in a hardware map and telemetry. You do need a hardware map because that's how you're going to get access to the motors on your robot. And these right here, these lines are lines that initialize your access to or for us, they initialize our access to the front left, the front right, the back left, and the back right motors. So we just are literally setting variables. And these variables, we set them equal to the hardware map .get of, and then this is right here where we specify which motor we want. And when you're setting up your robot, you're going to need to make sure that the wires are all connected to the right ports, and that you have correct labels on the phone that you're using that runs this code so that they match with these labels right here. And if that didn't make sense, you can look for videos about how to actually get the hardware map to work. So we start by setting the direction of the front and the back left, the front left and the back left, to be forward. Now, the reason we do that is because, and the reason why we need to set the front right direction to be reverse for both of these is because the robot needs to be turning, the motors on our robot are set up in such a way that some of them are flipped. And so if we were to set them all to be moving forward, then actually the robot would start spinning, or the robot wouldn't move correctly, because the orientation of the literal motors on the bot is different for each motor. And this may be different for you. Depending on how your motors are set up, you might need to play around with these values. For example, you could try setting this to forward, or try setting that to reverse, and see what happens. That is if your robot doesn't work. And then these lines of code right here just say that when the motors have their power set to be 0, they stop, they actively brake. As opposed to, for example, if your robot is moving really quickly and then you let go of the stick and it now has 0 power, it could just keep turning and use its inertia to move forward more, but we want it to stop. So that's why we have the zero power behavior, which is the behavior when it's at power 0, to be just braking.